Hello class, it's Miss Rania. Throughout this week, we are going to be continuing Chapter 10, Lesson 1, Classifying Matter. We'll find it in our copybook, in our textbook, pages 348 to 355. Let's take a look at our objectives and see what we're going to accomplish throughout this week. First of all, we're going to define the term substance. We're going to explain the different types of substances. There are two types. And we're going to conclude how atoms differ. When it comes to our keywords, we have four main keywords: substance, compound, element, and atomic number. So, we agreed on matter and atoms, right? Atoms can combine and arrange in millions of different ways. These different combinations and arrangements are what make up different types of matter. When it comes to the classification of matter, we have two main classifications: substances and mixtures. We are going to focus on substances throughout this week, and it's two types: elements and compounds. Throughout next week, we are going to be continuing mixtures. Okay, so what is matter? Matter is technically anything that has mass and takes up volume. So what's the difference between the matter that makes up wood and the matter that makes up water? Let's see how we can answer these questions. And our simplest question, what is matter? Which is anything that has mass and takes up space, which means it has volume. Let's start with our first classification, our main concept for today, for this week actually. A substance. A substance is matter with composition that is always the same. Simply, it means that a given substance is made up of the same combination of atoms. For example, aluminum is made up of an aluminum atom. Oxygen, made up of oxygen atom. Gold, made up of gold atom. Water, made up of a water atom. But here, what is a water atom? It's a combination of two elements, but with a composition that is always the same. We are going to talk more about this soon. Okay, so pay attention. Substances are chemically bonded, which means they cannot be separated by physical means. We cannot separate gold from other gold molecules. For example, here, a gold molecule, another gold molecule, another gold molecule. Atom. I will not say, no, I want to take this atom and break this atom. They really cannot be separated. Or water, for example. Water is made up of two components: hydrogen and oxygen. We have its symbol H2O, its chemical formula, let's say. We're going to get into more depth with the chemical formulas, don't worry. So the chemical formula is made up of two hydrogen and one oxygen. So what we can have is this cup of water contains one oxygen, two hydrogen, one oxygen, two hydrogen, one oxygen, two hydrogen. It's the same composition. It's not like we have one oxygen, two hydrogen, two oxygen, one hydrogen, one oxygen, and another oxygen, and no hydrogen. Here, the chemical composition or the composition is not the same. They're not all identical like here. So, when it comes to substances, they're chemically combined and they have composition that is always the same. Are gold and water the same? Think about it, and we're going to discuss it in our live session. Let's take a look at the classifications of substances. There are two main classifications of substances. We agreed that substances, same composition, first of all. Second, chemically joined. And finally, can't be separated by physical means, or can't be separated physically. So these This is the definition of a substance, and these are the classifications of a substance. An element, which is a substance that consists of one type of atom, only one type. For example, gold, Au. It's one kind only. Oxygen. Oxygen is a diatomic molecule. Why do we call it diatomic? Because it's the same molecule repeated. Di means two, and atomic from atom. So, what else is an example of an element? Helium, hydrogen. These are elements which are substances that consist of one type of atom, which we find in the periodic table. Compounds, a type of atom containing two or more elements chemically bonded. We're going to talk about compounds later. So scientists discovered 118 kinds of atoms. And where did they place them? So, periodic table. Periodic table is the most important thing in chemistry. It's where the 118 kinds of atoms are arranged. We're going to take a look at the periodic table and see how we can use it. So, these 118 kinds of atoms are listed in the periodic table, and we call them elements. Remember when we took last week the parts of an atom? Well, what makes atoms different is the number of protons. The number of protons gives different properties, and giving different properties means different atoms. This is how atoms are considered different, by the number of protons. Hello class. So we're still working on the same lesson. You're going to find classifying matter 348 to 355. Okay, throughout this video, we are going to get to know more about elements and compounds, the periodic table, and chemical formulas. So let's take a look at the periodic table and understand how we can find the number of protons. First of all, let's actually think of how we can know what these things are. This is how you are going to find a box in a periodic table. You're going to find the name of an atom, the atomic number, the symbol, and atomic mass. Okay, so what are these things? Let's think of it. Name and symbol are pretty clear, right? But what we're going to learn are the atomic number and the atomic mass. Let's think of another arrangement in which some periodic tables are arranged. Some periodic tables are arranged this way, other periodic tables are arranged just this way. We have first the symbol, and then, sorry, no, not the symbol. We have first the atomic number, and then symbol, name, and atomic mass. So, whenever you want to know the things or you want to know how to read a periodic table, these are the two arrangements that you have. Simply name, atomic number, symbol, mass, or atomic number, symbol, name, atomic mass. So what are atomic mass and atomic number? We're going to get to know them. Just wait. So here's our periodic table. Let's take, for example, argon. Argon, this is how it looks in the periodic table. The atomic number, the symbol, the name, and atomic mass, 39.948. So this is how you want to know what's going on. This is whatever you're going to see in the periodic table. You know what? Just keep it in mind this way. What's up is atomic number, what's down is atomic mass. This is how almost all periodic tables are arranged. Sometimes in some periodic tables that are mostly used, the atomic number is the first component in the box, not the name of the element. But what is an atomic number? Or what is an atomic mass? Let's take a look and see. An atomic number, do you know what makes, do you remember what we said in the beginning of the video? What makes atoms different and what gives them different properties? The atomic number is the number of protons in a nucleus. So, we already know protons are the big boss here. They change the properties of an atom, and they are technically in the periodic table right in front of us. So, atomic number, number of protons. What do protons do? Give different properties. So, we agreed that the atomic number is the number of protons in an atom's nucleus. How about atomic mass? From its name, we're looking at a mass. But which mass? The average mass. Average mass of an atom in an element. So, what if I ask you, what's the average mass of aluminum? Let's go back to our periodic table. Where can we find aluminum? Here it is. I asked for the average mass, or atomic mass. The last number, 26.082. Okay, what's the atomic number of cobalt? Cobalt is here. Remember, atomic number up, so it's 27. And the atomic mass is 58.933. So this is technically how we read a periodic table. Let's take more examples. Let's take details, let's say. Okay, so this is our box number 1 and box number 2. What do we want to find? Let's say we are gonna look for calcium. Where is calcium? Calcium is here. So simply look at the periodic table. First of all, atomic number 20, symbol Ca, name calcium, atomic mass 40.078. Think of the atomic number as the small number and the atomic mass as the big number. This is how it is always. So it's just to make it simpler. And you're going to have a copy of the periodic table to allow you to study. Let's take a look at magnesium. Magnesium Mg. Where is it? Here. So, first of all, we look at the periodic table, atomic number 12, symbol Mg, name magnesium, and atomic mass 24.305. So, if I ask you, what is the atomic mass of lithium? You're gonna go look in the periodic table, search for lithium, you're gonna give me the atomic mass. So it's really pretty simple. So now we are done with the periodic table. Let's continue. We agreed that substances are matters with composition that is always the same, and they're physically bonded and cannot be separated by physical means. So substance, first of all, same composition. Second point, chemically bonded. And finally, can't be separated by physical means, or can't be separated physically. What do I mean by physical means? Filtration, simply filtration, a filter, or a funnel, or a sieve tray, or evaporation. All these are physical means. that wouldn't separate substances. We also know that now we have two types or two classifications of substances. We have an element and a compound. So, an element, let's recall, it's a substance that contains one type of atom. So, how about a compound? We already got elements. We know how they are. We know how we can find them in the periodic table. We know how we can find the atomic number and the atomic mass, and we know what they are. So, elements, check. How about compounds? Well, think of it like this. A compound is elements together. So, a compound is a type of substance containing what? Atoms of two or more different elements. Chemically bonded, because we agreed substances are chemically bonded. Okay, let's take a look at examples. We agreed element, one substance, one type of atom. Compound, a substance, but two or more different types of atoms or elements that are chemically bonded. Let's take a look at some examples. As we take a look at these examples, we're going to get to know what a chemical formula is. Let's define a chemical formula first in order to see how it goes, to get to know it better. Chemical formula. A chemical formula is a combination of what? Two things. Of numbers and symbols that represent a compound. We always find chemical formula. Okay, so let's take an example of a chemical formula for compounds, for example. We have carbon dioxide. We agreed that di means two and oxide comes from oxygen. So here it's telling us we have two oxygen and one carbon. So we have CO2. This is our chemical formula for carbon dioxide. Let's take a deeper look. This is called a subscript. A subscript is the small number at the bottom. If we have no number, imagine it's an invisible one. Always no number, invisible one. Okay? So, the subscript tells us how many of this is present. For example, magnesium chloride, or let's say MgCl. No subscripts, so they're both invisible ones. So we have one magnesium and one chloride. Let's take a simpler example. Salt, table salt, sodium chloride. So NaCl. Also no subscripts, so we know it's an imaginary one. So we have one sodium and one calcium. Pretty simple, right? We already agreed that if there's no subscript, it's one. So one atom of this element is present in this chemical formula. Remember glucose? C6H12O6. You're going to take it in biology. It's called glucose. it's a sugar. Glucose is simply a sugar. So we have 6 carbon, 12 hydrogen, and 6 oxygen. Because we agreed that the subscript tells us what it is. And we already know the symbols. We can find them very easily in the periodic table. For example, oxygen, O, carbon, C, hydrogen, H, sodium, Na, barium, Ba, what else? Gold, Au. You can find them very easily with the periodic table. Okay, so to conclude our lesson, we are gonna see the difference between elements and compounds. So, elements, we agreed one type of atom. Compounds, 2 or more or simply more than one type of atom. What's similar is that they are both substances. See how in compounds 2 or more than one type of atom? So, do you think fluorine, Fl2, is a compound or a mixture? Or oxygen, a compound or a mixture? It's more than one, correct, it's 2, but of the same type of atom. So fluorine and oxygen are elements. Compounds like H2O, MgO, CO2, CO, all these, because they're different types of atoms, more than one type of atom. Okay, so what I need you to do, and we are going to discuss it in our live session, and you are going to give me the answer in posts. What is the atomic number of sodium, barium, calcium? What is the mass number of oxygen, nitrogen, and potassium? So here we have 2 questions. We are going to have 2 more questions. What is the symbol of? First of all, let's say helium, argon, and what can we else say else? Sulfur. So this is the 3rd question. And finally, chemical formula. What I need you to do is tell me what it presents. What does it tell you? 4, 1, MgO, 2, NH3, and 3, HCl. You are gonna tell me what this is, what is this, what are the subscripts, and what do the subscripts tell us? And I hope our lesson is clear. Okay, class. So in the first part of our video, we identified the meaning of matter. In this part, we are going to explore an atom and model the parts of an atom. Atoms are the building blocks of matter. Just like how cells are the basic unit of life, atoms are the basic unit of matter. Matter itself is made up of many kinds of atoms. It's a collection of atoms. Scientists discovered 118 kinds of atoms. and they placed them somewhere safe. So we have 118 kinds of atoms. These 118 kinds of atoms, the scientists organized them, arranged them, categorized them, and put them in a table called the periodic table. So, okay, so do we call what's in the periodic table an atom? No, we call them elements in the periodic table. This is a picture of a periodic table. Inshallah, next week we're going to go into its details. But what I need you to know for now is that atoms there were 118 kinds of atoms. We call them elements. And they are placed in the periodic table. We have beryllium, magnesium, sodium, calcium, potassium, oxygen, nitrogen, carbon, fluorine, chlorine, bromine. All these are elements in the periodic table. Everything in the world is made up of atoms. From the computer screen you're watching the lesson on to the eyeballs you're watching through. Everything is made up of atoms. Even cells. Cells are made up of atoms. How? Aren't cells the basic unit of life? And atoms are the building block of matter. And matter is anything that takes up space and volume. And our cells, which is us, we take space and volume. Our cells in our body take up space and have mass, have mass and take up space. So, when we actually want to define what an atom is, an atom is a small particle that is the building block of matter. Simply, we already agreed that atoms are the building blocks of matter, right? Building block of matter. Okay, so now we know what an atom is, right? It's a small particle. We can find them in elements in the periodic table. They're the building blocks of matter, simply. Okay, so let's take a look at the parts of an atom. An atom structure is simple. So let's focus and learn it together, okay? I really hope you get it clearly because it's pretty simple. So what makes up an atom? First of all, the nucleus. A nucleus is the first and most important part of an atom. We also have neutrons here, protons, which are filled. They're not hollow, they're not empty. Electrons are not inside the nucleus, and the electron cloud. Okay, so atoms are made up of 3 types of particles, and each of these tiny particles have something special on its own. Say, let's go and take a look at these particles. Let's start from the biggest. We agreed that a nucleus is the center of an atom, right? So, a center of an atom that has 2 particles. What are these 2 particles? Do you remember from the names? Do you remember the picture we just saw? There are 2 particles inside the center of a nucleus. They're subatomic particles called protons and neutrons. So, inside the nucleus, we have protons and neutrons. So we defined the nucleus. We found out that inside the nucleus there are 2 subatomic particles, protons and neutrons. So, okay, what about protons and neutrons? What are we gonna know about them? Well, keep in mind, we have a proton. You have to know 2 things about each element: location and charge. So a proton is located inside the nucleus. So this is a location. How about the charge? Protons have positive charge. Okay, I'll show you how to link it really simply. P. Proton, positive. Think of it like this. Positive proton, double P, okay? How about the second subatomic particle that is in the nucleus? The second one is the neutron. Okay, what is the location of a neutron? Also in the nucleus, or we can say in the center of an atom. Okay, how about the charge? Its charge is also related to its name. That's how we can link things to be able to keep them in our minds. A neutron has no charge, no electric charge. If you have no charge, you're neutral. So, just like we mixed P and P, positive proton, nu and nu, neutron and neutral. So, neutrons are neutral. Okay? Mix it, think of it like this. Okay, sorry. And mu. So, neutron are neutrals. These two are in the center of an atom. Okay, how about the rest of an atom? Okay, we're gonna talk about it. The rest of an atom, simply the electron cloud. Think of this as the nucleus with the proton and neutron, and we have an electron here. Okay, so we already agreed protons are neutron and neutrons. Protons, PP, positive proton, neutrons, nu nu, neutrons are neutral. How about this? What is this? These are the electrons. Electrons are located where? Also, location and charge are very important. It's located in the electron cloud. Is the location. Okay, so all this, can you see these lines? It technically spins and spins. So all this is the electron cloud. What is the charge of electrons? Charge negative. This is why I told you neutrons neutral. We linked it as an U, not N. Electrons negative. I hope it's clear. Okay, so what is an electron cloud? Let's define it. Electron cloud simply, it's the area surrounding the nucleus. So this is the definition of an electron cloud. Inside the electron cloud, we have electrons that are negatively charged and are located in the electron cloud. Some atoms, like oxygen, have the same number of protons, neutrons, and electrons. For example, oxygen, protons, neutrons, and electrons are all 8. We are going to get to know how we know this, inshallah, next week when we get to know the periodic table more. But keep in mind that not all elements have the same number of electrons or same number of protons. We have lithium. It has proton, neutron, and electron. It has 3 protons, 4 neutrons, and 3 electrons. Okay, so what makes things different? What characterizes the characteristics or properties of an atom? Number of protons. The number of protons, we can say it differs atoms' properties. With many different numbers of protons, we have many different properties in elements. Let's say elements, because we're taking them from the periodic table now. Okay, so let's try and sum up the core of the lesson. Okay, so we have location and we have charge. Proton, neutron, and electron. Okay, So protons are located inside nucleus. Or we can say center of an atom. As we already know, this nucleus is the center. Remember, proton, positive. PP, positive. Okay, neutrons, where are they located? Also, center of nucleus. Center of atom or inside the nucleus. Charge, neutral, no charge, no electric charge. And finally, electrons in electron cloud. This is the easiest one to remember really, because electrons should be in the electron cloud, of course. And they have a negative charge, negative. I hope this part of our lesson was clear. So we concluded that atoms have three main parts, three subatomic particles, protons, neutrons, and electrons. Also in an atom, we have a nucleus and an electron cloud. The nucleus is the center of an atom, and electron cloud is where electrons flow, the area around a nucleus. So we fulfilled our second and third objectives. What we did was we got to know the parts of an atom and we modeled its parts. I hope we're clear. Please don't hesitate to ask in our live session and office hour timings. Also in the morning. Hello class, it's me Sirania. Today inshallah we're going to be starting chapter 10, Foundations of Chemistry, lesson 1, Classifying Matter. We're going to find it in our textbook, pages 348 to 355. Let's take a look at our objectives, the things we're going to accomplish throughout this video. First of all, we're going to identify the meaning of matter. In the second part of our video, we're going to explore an atom and model the parts of an atom. We have four main keywords: matter, proton, neutron, and electron. Okay, so what is matter? You might have heard that everything is made of matter. Okay, that's true. Everything is made of matter. A book, a rock, water, even you, your iPad, your laptop, everything. But what is matter exactly? I hope you remember from last week's revision what matter is. Matter has two conditions. First of all, it's anything that has what? In order to be matter, you have to have two main things. First of all, mass, and takes up space, so volume. So matter is anything that has mass and takes up space. We already know about mass. Heavy things, how heavy something is. Like if we've ever been to a doctor's office, the first thing they take us to do is stand on a scale to know how much we weigh or what our mass is. But something we really can't argue about is that all matter has volume as well. Volume, I hope you remember from last week, it simply fills the area, takes up space, the amount of space something occupies. For example, when you pour water into a glass, the water's volume is the amount of water it fills in the glass. So we agreed that matter is anything that has mass and that has volume, right? Okay, and we know there are three states of matter. I'm sure we all know the three states of matter: solid, liquid, and gas. Let's pay attention at gas for a moment. Air. Air is a gas, right? Okay, I'm gonna show you a video now and we're gonna discuss it in our live session. But think about it. Is air matter? So, we identified what matter is. We looked at the states of matter. So our first objective is now fulfilled. But right now, you're going to be watching a video after this part. And then we're going to continue to our part 2 of the video to complete the 2 other objectives.
Hi, I'm Jared and welcome to Science Demonstrations for Young Learners. I have my hands full here because our big idea is quite interesting. The big idea is that air is matter and air has weight. Science tells us that air is matter and air has weight. So how do I show you that? Welcome to my scale. I have a neat balance here that almost is balanced. Hey, it's working pretty good. I have two balloons and I want to show you that air has weight, so I put air into them. So what I'm going to do is I'm going to remove the air from one of these balloons. We're going to go with this one right here. So if I take the air out of this balloon and this balloon still has air, it should be heavier. Let's see if we can get this to work. Okay, I've removed the air. It's slowly leaving the balloon. Whoa, it's swirling because I get a force pushing on my scale. I'm going to stabilize it just a little bit and watch the science happen. Wait a second. It's spinning. I'm going to stop the spinning. Oh, look! This is heavier. Why? There's air in it. There's no air in this. Air, no air. Air actually has weight. It's heavy. Science is cool. Thanks for watching.